All right, welcome everyone to Mr. P After Hours here. It's still the same day that we did our CS135 review. I've decided that I would like to do my best to stay on schedule as much as possible, so I'm just going to film this hopefully quick little video to finish up our CS135 review. All we're going to do is finish this program so that you have a very good reference for your assignment. All right, so in class, we got pretty far, but we didn't do nearly enough. If you recall, we did our read file function, which works very well. We also figured out how to do Linux redirection in the sense that we're going to open this file, and the file is provided via the command line. All right. And that's pretty much all we did. We talked a little bit about structs. So we're going to continue on with that. And we're going to finish the definitions for these functions here, okay? So we're going to go ahead and get started here. Now, these structs are based off of your assignment. At least this one is. This may be very comparable to a unigram. But instead of an actual word, we're only going to be keeping track of single-digit numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And basically, we're going to go through this, this file here, and we're going to count the number of each number, that is. So you can see we've got a 2 here. Looks like there's 3 of them there, but as you can see, there are also, there's a 2 there, another 2, and another 2. So pretty much we're going to have to convert all of these words into numbers. You're going to have to pick and choose some of the stuff from this example to go into your assignment if you'd like. But we're going to go ahead and do a few things. To start, let's go ahead and make a clean word function. Now what this clean word function will do is it's going to, let's see here. Let's add some nice comments for this. This clean word function will take a string and it will remove all non-alpha numeric characters. So that basically means it's going to take out all those kind of weird punctuation things. Here we've got an underscore, we've got a few periods here, a question mark, a quote. So it's going to kind of take those things out. It's also going to convert each character to be lowercase. All right, so it's going to make the string lowercase. Now, this is a little bit different than your assignment. I'm not just going to give this one to you. But in this example, there are no letters and numbers together. So what I mean by that is there's nothing here that's like, I don't know, like this, where you've got a digit here combined with the letters. In this example, we don't have any of that, but you will have to deal with that in your assignment. I'm going to leave that up to you. So just keep in mind that if you are going to take this clean word function and modify it a little bit, it won't work perfectly. You're going to have to add a few things. So the first thing we should do is let's remove all of these non-alphanumeric characters, all right? Now, there's a fun little function that I mentioned, which is called is, and I'll have to check, but I think that's what it looks like. And what this stands for is it alphanumeric. Is the char, it takes a char as a parameter, is the char alphanumeric. All right, and there's also this one, is the char alpha. So is alpha kind of does the same thing here, except is the char just alpha? Is it alpha? Is it a letter? All right. So this one handles letters and digits. This one just handles letters. Now, since I said that if it's just a number, we're not really going to have to check for that thing. So I'm actually not going to use alphanumeric check. I'm actually just going to check for is alpha. All right. Now, we could use a few things. I'm going to go ahead and reference Google here, my favorite thing. And I think there's probably a function called isNum in C++. IsDigit, rather. So let's go ahead and throw that one. This one you probably won't have to use in your assignment, but I'll probably use it here. All right. And this will take a character, and it will tell me, is the char a digit? All right, so I'm going to kind of use just these two here. In addition to that, two lower, we'll take a character C, and it will return the lowercase version of that char. All right, so in turns, A will become A, but A will remain A. All right. So kind of a nice universal function there that we'll use. So let's go ahead and get started. Now, if you did check the Discord, you'll notice that the first thing you have to do in the assignment is to remove all of the non-alphanumeric characters, and then you'll worry about the number part. So we'll kind of take that same approach. So the first thing we're going to do is remove all non-alphanumeric characters. So we're probably going to need to go through our string character by character. All right. Now that'll be pretty easy. Luckily for us, we've got a nice for loop here. For int I is equal to 0, I is less than s.length, I++. So that for loop will go through each character in the string. And we can do a nice if check here. And we can say, hey, si will return the character at that string. Right? So if I've got my string here, my string, s at 0 returns m, s at 1 returns y, s at 2 returns s, so on and so forth. So I can check to see if that character is alpha. And if it is, we want to keep it. Else, we'll probably throw it away. Now, I did forget a little bit here. Notice that we've got some digits in here, so it's probably best we take care of that first. So let's go ahead and do that. We're going to say if is digit s located at 0, and that's totally okay. Maybe we should check to make sure that our string actually has characters in it to begin with. So let's do actually quite a few checks. Let's say, hey, if s length equals 0, then we know that this is the empty string. So we could probably just return s. Likely, an empty string cleaned is still the empty string. Now, if we check for the isDigit part, we know at this point that the length is not equal to 0. So we know that this word has at least one character in it. And so if the first character happens to be a number, I'm just going to assume here that we know that it's a digit. All right, so we're going to say, hey, if this is a digit, and if we want to be even more careful, s.length equals 1, then we can go ahead and just return s again. All right, so there's nothing to clean here. There's nothing to clean in an 8. There's nothing to clean in a 9, so we'll go ahead and just return it. Now, I'm going to put an else there, though it's not required. And then another thing that we could check for is probably this, if you really wanted to. Well, let's not go there. So at this point, this is the empty string. This is a single digit. And now we've made it past that part. So we have a string. We have a string now. So we'll continue on here with our, I guess I'll say a word, with our original for loop that we wrote, in which we're going to go through it care by care. And we're going to determine which characters we should keep and which characters we should throw away. So if we check that this is alpha, we're going to want to keep it, else we're going to want to throw it away. So how are we going to keep it and how are we going to throw it away? You may ask, how are we going to delete this from a string? Well, let's not delete it. How about we actually leave this string as is? We're not even going to edit this parameter. Let's just make a brand new one and use what we call concatenation. So let's say I declare a string, new string, and I say, hey, this is equal to our empty string. All right, this string is empty. And as we go through character by character and we find new characters to add on to it, we will just put them in this new string. So if I determine that this is an alphabetical character, this is a letter, we could say something like, hey, the new string is equal, now I'm going to use this plus equals thing, to SI. Alright, now before we move any further, I just want to remind you that this plus equal thing is just the same thing as this, plus SI. And if you don't know what plus means concatenate. So if I were to concatenate something, for example, I'm going to make my cat's name here, Patty. If I were to concatenate PAT plus TY, we're going to end up with a full string here called Patty. So that's what this plus sign does, all right? It's going to concatenate things. So in this sense, if we find an alphabetical character, let's go ahead and concatenate it with the new string. So the first one we find will be the first character. The second one we find will be the second character. So on and so forth. Now let's take it one step further and let's say, hey, let's go ahead and make that 2 lower. What do you say? Let's go ahead and make that 2 lower. So we'll kind of kill 2 birds with 1 stone here. We'll be eliminating the things that aren't letters, and we'll also be converting them to lowercase. Else, we don't really care about it. So in fact, there's nothing to do here, right? We're not going to add it to the new string. In some sense, we can just delete that part. And then when we're finally done, we can say, hey, here's my new string. This is a cleaned string. All right, that is our first function. Let's kind of run through it real quick again. First, we'll see if it's empty. If so, we'll return S. Next, we'll see if the first character is a digit and the length of this string is it's 1, meaning we are looking at an 8, a 4, a 7, or a 5. We'll go ahead and just return it. Else, we'll declare a new empty string, and then we'll go through the parameter string one by one, and we'll convert each letter to lowercase. So why don't we test it out? What do you say? What do you say? Why don't we test it out? So I'm going to come back up here in our main. I'm just going to remind you what we're doing. If we manage to open this file and we read in all the words, then I go through each word in the array and I print it out. So let's kind of do like a logging thing here, and let's say, hey, maybe I would like to see how this thing changed, all right? I'd like to see how this thing changed. So I'm going to go ahead and put maybe just a few things here. Now, I may end up making things vertical. You may have never seen that before. But just because my text here is so big, I kind of don't want to run off the side here, so I'm going to kind of build this downwards. So the first thing I'll print out is the I, and then we'll go ahead and print out the original word. And then whatever that word becomes. So we're going to clean the word. Let's see here. Clean word. Words I. And that should do it. So let's go ahead and test this out. I'm going to come back here to Bobby. I'm going to have to remind it that I want to log back in. And I should be able to grab my file here. I did change the name of this file. And it seems here I made a mistake, which is something that I often do. But that's just because I forgot something. So we'll go ahead and throw that in there. And we'll give it another shot. What do you say? Things went well. Let's see if it works. So as you can see, it looks like we have about 63 total words in the file. 63 total words. And so each time we find one, I call clean word on it to see what it becomes. So you notice that this 2 stays the same, the 8 stays the same. But when we get down here, you'll notice that this 6, we lose this quote and the S becomes lowercase. And as we, excuse me, as we get here into the later rounds, you can see that we're really cleaning some of these words up. You can see we're really cleaning some of these words up. All right, so that should give you an idea how to log something like this. Now, you're probably going to have to check and see if you want to log this thing, right? So it looks like, based off the assignment, though I'm not sure, let's go ahead and take a look-see at our solution while I have the option. We have to keep track of the things that we're logging, and I'm not sure exactly what we'll log. So you notice here that this is logged, but I don't think changes to the case is logged. So if the word contains punctuation or some symbol, I think that it's logged, but if it's just a case change, meaning if we had something like machine becomes machine with a lowercase, I do not think that's logged. So you'll have to do a little bit of a check there to see, I don't know, maybe the lengths of the strings are the same. I'm not too sure. I'll leave that one up to you. But your job, I think, is here only to record in the log words that are changed based off of whether or not they contain a symbol or not. The case changes are not recorded. All right. I did upload that file, so you're totally welcome to look at it. And so that's our clean word function. So the next thing we'll consider is this convert word function. All right, this is just going to convert a word to a string to a number. All right, this one should be pretty easy. This one won't necessarily help you with the assignment too well, so I'll just kind of speed run through it. All right. So I would love to use a switch statement here, but switch statements only take kind of numeric if checks. All right, so it only checks for characters, ints, things like that. A switch statement, if I were to type with a string S here, would not really work, I believe. So I will not do it that way. Rather, I'm just going to do a bunch of if-else checks. All right, I know that might seem pretty ridiculous. Maybe we could have a little bit of fun with it instead. How about we make some arrays? So let's go ahead and make a string num array. And let's say it contains 10 strings. And that might be equal to all of our digits, right? So that's 0, that's 1, that's going to be 2. Three, 4, 5, 6, 7, 8, and 9. All right. So now we have a fun little array here. Say number array. We could say maybe constant size array equals 10. And we could probably throw that in there if we wanted to. No magic numbers here, you know. And now we'll make the same array, but this one is going to be num array C maybe for conversion. And that will convert 0 to be the digit 0. So let's give that a shot, all right? I'm just going to do it the exact same way here. And instead of 0, we'll have that. 1, 2, 3, 4. There you go. So there's our converted number array. So let's do a few things here. The first thing I want to check for are these ones. I want to know, hey, do these words, or are these words digits? Are they numbers? So we can actually do the same check that we did up here. So let's check to see if the, well, let's do a few things here. Let's do a fun few checks. First thing, let's go ahead and check that length because I don't want to index anything out of bounds. All right, so notice here that I'm indexing this string. Now, before I do that, I want to make sure that the size is at least 1. Otherwise, our program might break. So I'll go ahead and check this here to see if it's an empty string. If it is, maybe we'll return -1. That could be maybe our error. That's be our error number. Else, if let's say this is a digit and the length is 1, we can actually return almost kind of how it is, right? Except here's the thing. We need to convert, say, a string that contains 2 to the actual integer 2. Now, there's plenty of options for this. My favorite is just to reference the ASCII table. So if you Google ASCII table, there's a nice website here. And you can actually see all of the characters. It might be a little hard to see. But you'll notice that each character, for example, say the 8 here, it has a decimal representation. And so, in fact, the 8 character is actually equivalent to a number 56 integer. So, in fact, if I wanted to convert these to the actual decimal values, the decimal values are up here, the characters are here on the right side. Essentially, I'm just going to take, hey, let's take this 0 minus 48, and that will give us the actual decimal value. So check this out. Now that's a magic number there. I guess we don't want to do that. So I'm going to call it the care shift. The care shifter equal to 48 there. And we'll go ahead and subtract it off. All right. And that will convert, say, our character 2 to a actual decimal 2. All right. Else, we are going to be converting this. So I'll actually just do a for loop, and I'll go through each one. This is pretty handy here. Let's check this out. For an I is equal to 0, I is less than the max array, or the array length, that is. Size array, I guess I called it. I++. I'll check to see if our S is equal to the num array located at I, all right? So essentially, I'll say, hey, is this string here equal to 0? Or is it equal to 1? Or is it equal to 2? And if it is, then let's go ahead and return the number array converted located at I. So check that out. Check that out. So let's say I find it here at number 4. This is the 1, 2, 3, 4, fifth element in this array. This is the fifth element. So if I find it here, then I'll go ahead and return the fifth element in this array. 1, 2, 3, 4, 5. So I'll find the 4 and I'll return a 4. So that's what this for loop will do here. Now, if somehow we make it down to the bottom here without returning, which we shouldn't, but if we do, then we're going to return -1. That will be our nice little exit. This is an error, and we'll be able to see that. So let's go ahead and check out this convert word function. Let's see how we did. So up here, I will come back to our cout, and I will add some more stuff. Now notice here, this might be a little scary to you. I haven't saved this anywhere. So when I call this function, it returns a value, but I'm not storing it anywhere. So if I want to get the cleaned word again, I'll have to call it here, and then I'll have to pass whatever that returns to the converted word. So let's go ahead and check that out. Looks like we've got an error, as I always do. I'm sure I missed some insertion operators. Or I put a semicolon there, that's fine. We all make mistakes here. We always will. Nobody's perfect. Input file.txt. And what do you know? It looks like it works beautifully. 2 becomes 2 becomes 2. 8 becomes 8 becomes 8. 6 becomes 6 becomes 6. 1 becomes 1 becomes 1. This becomes that. Looks like it's working nicely. It looks like it's working beautifully. All right, so it looks like we did a good job. So let's go ahead and continue on. So my goal would be to do something like in the assignment where I keep track of the number of numbers. The number of numbers, the number of each number. So I'm going to do this clean array. I'm going to do this clean array function here, which will actually just take this words array and it will store it into this struct number dictionary, all right? Now notice, I guess I'll get started here. Now notice I'm passing this by reference. All right, this means pass by reference. What this function will do is it will take the words array, and the first thing it does is it cleans the words, then converts the words, stores stores in the ND and updates the ND frequency, pretty much. So you see what I mean? Now, notice it's passing by reference. That's because I'm going to edit this. Somewhere down in this function, I'm going to say ND num array located at, say, the nd.array size or something like that. I'm going to assign some value to it. So I can either do it one of two ways. I can either pass this as a reference parameter, or I can make this function return a brand new number dictionary. And for the sake of reference, reviewing our pass by reference, I'm going to go ahead and just pass it by reference. All right. So this is pretty simple. There's one thing that I need to do here. I need to know how many words are in this array, so I want to pass that in as well. All right. And how are we going to call it? Well, I'm going to delete this stuff here. That was just for me to prove that things were working. So what I'm going to do now is I'm going to make first my number dictionary. This is very simple. All I have to do is type number dictionary ND. And then I want to store all the words into the ND. So what I'll call here is I'll call clean, how do I do it? Clean array. I'm going to rename it something. Clean and store. I prefer that much better. And that it will clean every word, and it will also store them into the number dictionary. So clean and store the array. Where are we going to store it? Well, we're actually going to store it in this number dictionary here. Remember, this is a pass by reference. So whatever this function does, however this function decides to edit the number dictionary, this will be edited as well. We're passing the reference. In addition to that, we're going to pass in the words array, and we're going to pass in the word count, or words read. All right. So let's go ahead and do that. So in this clean and store array function, pretty much, I'll do a for loop. I is less than, let's say, the parameter I forgot here. What is that called? Well, we'll call that the word count, something like that. So for I is less than our word count, I++. Let's go ahead and go through each word. First, we can clean it. So I'll do this kind of step by step to begin, but it can actually be really condensed if we'd like it to. So this will be the cleaned word equals clean word, the words array located at I, so that'll clean the word. The next thing we'll do is convert it is equal to the converted word, cleaned word. All right. So that converts it. And then we'll need to insert it to the number dictionary. So there's kind of a little bit of work that has to be done here. So all we'll do is this. This will be a little bit complicated, all right? So the way to think about it is the number dictionary kind of looks like this. So it's going to have probably a 0 and then some frequency, right? So what we expect it to have is a place for all the numbers. It's kind of what our number dictionary will look like. Now, to begin, the number dictionary is actually empty. So if I were to kind of wrap this in some brackets to prove to you that it contains something, the number dictionary might start out kind of like this, where it's empty. So we're either going to have to insert it, or we're going to have to go find it. So the first thing we need to do is search the dictionary for the number to see if it already exists. Search the dictionary for the number. Now, how are we going to keep track of whether or not we found it? We'll keep that in mind, but I like to use a bool for this. We say at the beginning we haven't found that word yet. We haven't found that number in the dictionary. And so we'll go through this array. We can do it two ways. Int index found. We'll say -1. So did we find the number? Where did we find it? So for int, this is going to be a for loop inside of a for loop. So we'll do for int j is equal to 0. We need to go through every element in this number dictionary. So all we have to do is check for j is less than the number dictionary's size, I++. Now that reminds me, when we declare this number dictionary, we have to be sure to initialize that size to be 0. All right, we have to be sure to initialize that to be 0. Otherwise, it will contain some garbage value and we'll end up with some problem here. All right, so we'll go through the whole array and we'll say, hey, if the ND, the num array located at j is equal to our converted word, means we found it, right? So found equals true. And where was the index at? Well, the index that we found it at is equal to j. Now I'm going to use something called a break statement here. I'm going to go ahead and open up the notepad real quick just to talk about that. That's the wrong notepad. What does a break statement do? Well, break statements will it breaks out of the nearest loop and it will continue program execution on the line after the loop. All right, so what I'm saying here is, let's say I found that number inside of the dictionary. If I found it, then I'm going to go ahead and break out of the nearest loop. Where's the nearest loop? It's this entire for loop. So this break statement will actually take me to this line here. All right. Break will take me right there. So now we're going to do some if checks down here. So in this little for loop, we're going to go see if we can find that number, and if we found it or if we didn't, it's going to affect what we do. So first thing we'll say, if we found it. It's pretty simple. All we have to do is say if found. Then inside the number dictionary, at the num array, at the index found. Now this is going to be a little tricky for some of us. Notice that this is a struct inside of a struct. It's a struct inside of a struct. What does that mean? What does that do for us? Well, if you think about it, we're going to have to access these variables within this array. So we're going to use the dot operator twice. We're going to use a double dot operator. So first, I'm just going to put parentheses here. It's not required. But these parentheses will indicate that this makes a number dictionary. And then we're going to go into it and find the number inside of the array. So this whole parenthesis thing actually just becomes a number. So I'll call dot again, and I'll say, hey, frequency plus equals 1. All right, if we found it, go inside of the number dictionary, go to its array. We have the index that we found the number at, and let's go ahead and increment the frequency, meaning we found that number at least once. Or at least twice, I'd say. Else means we didn't find it. So we need to insert it. We need to insert the number. So where will we put it? Well, let's go ahead and put it at the end. So if you think about it, the first thing that will come in here, it looks like 2. So inside this number dictionary will come in, and it will be 2, 1. And let's say the next thing we insert is an 8. Well, there's no spot for the 8. There's no spot for it. I'm a little mixed up here. There's no spot for our 8. So we're actually going to have to increment the array size and put it in there, all right? So this is pretty simple. All we have to do is this. I'll take this ND number array, and this is going to be at some index. How do we know which one we go to? Well, it's going to be the very last element in the array. So for example, let's take this current number dictionary. The size of this number dictionary is 2, because there's 1 entry, 2 entries. Now this is at index 0, and this is at, index number 1. So where are we going to put the next one? It's going to go at index number 2. Now check this out. This is a fun little comparison. Notice that this 2 is the current size of the array. The current size of the array is always 1 greater than the number, or than the indexable. I need to rephrase that. I'm going too fast. The size of the array, you can never index an array at its size, right? You can only index it at the size minus 1. So if you take 2 minus 1, then you're going to be able to index that last element. Now recall that this array has a size of 100, so we won't go out of bounds. We're just going to keep track of how many elements are in that array. So if I want to insert it, the code will kind of look like this, where we say the num array located at the size is equal to, say, our new number. So check this out. So it's not at the index found, rather it's going to be at the ND array size. So inside the number dictionary we have the array, and inside the number dictionary we also have its size. And so at that size we're going to have our, what's it called? The converted word. And then we also need to do one more thing. The first thing I need to say is it's the number. Are you confused yet? I imagine that you are. And this one, frequency, it's going to say 1. So if we find the very first 8, we're going to put it into the array. We're going to say that its frequency is this, and then we can say that the ND array size is now greater than it's now greater than 1. So this insert the number, record the frequency, and increment the size. So I know that's probably a little bit scary, but we're going to see how well we did. So let's just kind of reiterate what we did. We're going to go through every word in the array, every word in this array. We're going to clean the word. We're going to convert it to a number. We're going to determine whether, we're going to keep track of whether we then find it in the number dictionary, right? So the number dictionary could be empty. It could contain all of the numbers already. So we have to remember whether or not we found it. So for each word that's in this array, we'll then go through the number dictionary. And we'll say, hey, for every number in the number dictionary, did we find this number? Did we find this converted word? If we did, then we found it. Let's remember where we found it, and let's break out of this for loop. Now down here, if we found it, all we have to do is increment the frequency. But if we didn't find it, then we're going to have to insert the number. We're going to have to initialize its frequency, and then we're going to have to increase the size of the number dictionary. So let's actually see if this worked. All right, let's see if this worked. Now, real quick, I just kind of want to point this out. I tried to make this nice and broken out for you to understand, but I could actually kind of save some space here if I wanted to. Just like that. 2 function calls here. Now, this is a problem. As you can see, I've named the things the same. So I'm going to have to rename those. All right, so that should fix our problems. Now in main, what are we going to do? Well, we're going to clean and store this array, and then let's go through each thing in the array. All right, so I'm going to use another for loop. For int I is equal to 0. I is less than the nd.array size. I++. Let's go ahead and see out the nd.numArray located at I.number. Let's throw a comma in there, and then let's do the same thing for the frequency. And then we'll throw an end line on there. So this will print out what the number is and how many times it's in the file. So let's give it a shot. And then we'll actually almost be wrapped up with this. It looks like I have a problem here. Looks like I've got a problem. So let's go ahead and figure out what I did wrong. Now, this is a very disgusting error. I've kind of zoomed out here. You probably can't see it very well, but this is just disgusting. So in order to handle this, just come up here and find where you compiled it. And you'll notice here what it doesn't like is this comparison. Now notice here it says this is a number type and this is an integer type. So in fact, what I have to do is I have to come down here, and whenever I do this comparison, I actually have to say the number. Now, that almost worked. Now we've got, it looks like I was correct. It looks like I was correct in whatever I was talking about. And I have called this function incorrectly. So we'll fix that. And finally, we will give it a shot. Now it looks like we've got an infinite loop going on here. If you ever get an infinite loop, go ahead and type XC. That will exit us out. Let's go figure out where our infinite loop is. So I know that my read file function works. That's not a problem. So our infinite loop is either happening here or it's happening in here. So let's figure this out. See out, about to clean, and then about to print. Now if we run this, you'll see that we get stuck here. We get stuck here at the about to clean section. What happened there? Well, let's see how I messed up. So in this clean and store array, I've got a problem. So for everything in the words, I'll convert it. I know that this line of code works. Now this is probably where our problem might be. So let's see. Let's see what we messed up here. Yeah, that should be fine. So something's going wrong here. Now I think that this is probably okay. And we might be getting stuck right here. You can see that I have an issue here. So that I++, that was very silly of me. Some of you may have noticed that. But we found it. So let's go ahead and not do that, but rather recompile. There we go. And this does not look correct, though it would be amazing if that's how it actually was. I must have done a copy-paste here. All right, that's much better. So there's our number dictionary, all right? Looks like 2 is in there 7 times. Let's check it. That's 1, 2, 3. And if I actually find the value, that's 1, 2, 3, 4. So that's 3 plus 4 is 7. So that kind of handles that bit. So now finally we're going to sort it and we'll call it. All right, we'll call it. So let's go ahead and make a sort function. Looks like I already got it here. This one will be super easy. I'm just going to give it to you, since many of you haven't done it before. So, in order to sort, we're going to call this a nice bubble sort. And for this bubble sort, I will talk about it later, all right? But here's how it works. For I is less than 0, I is less than the nd dot, whatever the size of the array is, minus 1, I++. Then we're going to do another for loop in here. Be careful to make sure your i's and your j's are different. So this is going to be int j. J is less than the array size minus I minus 1. J++. And then we're going to do some check. Now we can either sort on the number or the frequency. I'm going to just pick one. Let's say nd dot the number array located at j, and let's just compare the numbers. If that's less than, say, the nd number array j at j+1, then we're going to swap them. All right, then we're going to swap them. So we actually have to swap the whole number. This is pretty simple. All we'll have to do here is make a temp variable. And we're going to say, hey, that is equal to the number array at j. And then we'll say the number array at j is equal to the number array at j+1. And then the number array at j+1 is equal to temp. And that's it. That's the sorting function. Notice that this is passed by reference. So whenever we make a change to it, it will happen in the, it will make a change to the actual reference. It will make a change to that original variable. So we'll print it twice. What do you say? And in between, we'll go ahead and sort our dictionary. Let's give it a shot. And what do you know? Here's the unsorted list: 2, 8, 5, 1, 6, 4, 3, 9, 7. Now we've got 9, 8, 7, 6, 5, 4, 3, 2, 1. Now if I wanted to sort on the frequency, it's very easy. Just pop down here and change this. All right. Now finally, if we want to write this to a file, I'll kind of just leave this with you. If you want to write it to a file, all you have to do is open up an OStream, outfile, outfile.open perhaps. I don't know what you want to call it, but we'll call it maybe numbers.txt. And then all you have to do is this, but instead of cout, use the out file, and then close your out file. So when that assignment program asks you to do something, for example, save the unigrams, save the bigrams, or save the log, all you have to do is open an out file and run it. Now if I refresh my little thing in here, or I say ls, you can see that numbers.txt now exists. My face might be in the way, so I'll see if I can scroll down there a little bit. And I can open it up here in MOBA, and you'll see that, though it probably won't let me zoom in here, which is ridiculous. I can bring it over here, and you'll be able to see that that is a sorted list by frequency. So there you have it. That's your helper code. I hope this video helped you. I know I probably went a little too fast, and I also know that you didn't have any chance to ask questions. So please give the assignment a shot. If you have problems, message me, and I'll check in with everybody later, probably on Sunday, to see how we're all doing. And if we're having some major problems, then maybe we'll spend some more time on it. Thanks for watching the video. I'll see you guys on Tuesday.